Welcome to qnawire.
Okay, so this is the motion of a diagram for the cards. So at time equals 0, speed is equal to 0, and acceleration is pointing toward the left, which means that net force is going to the left. So there should be a capital F force here to the left, and there should be a friction to the right to oppose the motion, okay, because the surface is a rough surface. And then at time equal to t over 4, acceleration becomes 0. That means there's no net force anymore along the left direction, okay, but there's a friction acting on it. So therefore, the friction is trying to oppose the motion, so it's toward the right. And then at time equal to t over 2, speed becomes 0, but there's acceleration toward the right, which means that there should be a force toward the right and the friction toward the left to oppose the motion. And then at time 3t over 4, acceleration is 0 and speed is toward the right, which means that there's no force pointing toward the right, but there should be a friction toward the left because it's trying to oppose the motion. And at time equal t, speed becomes 0, acceleration toward the left means that there should be a force toward the left since there's acceleration toward the left, and there should be a friction toward the right to oppose the motion. And this is 0 points, amplitude, and negative amplitude, okay? And this is the energy bar charts for each time, okay? So at time equals 0, well, so it's at the maximum displacement here, which is amplitude here. So therefore, the potential energy is at the greatest, and the rest of it is 0, okay? Because they haven't moved yet. And at time equal to t over 4, part of a potential energy converted into kinetic energy because now it has velocity, but and also some of it was converted into the changing internal energy since the car start moving, so the car will gain some internal energy by hitting out the rough surface, okay? Because it's not a smooth surface, it's a rough surface. So there's some friction going on when the car was moving around the rough surface. So there will be some changing internal energy in the cards. And then at time equal to t over 2, those kinetic energy was converted into potential energy. But since there was a motion before, that means the changing internal energy was also gained when the car was hitting other surface, okay? And then at time equal to 3t over 4, those potential energy converted into kinetic energy, and the changing internal energy is still the same because there's still a motion going on the rough surface. And then at time equal to t, kinetic energy was converted into potential energy, and then changing internal energy is constant as well, okay? And then this is the position versus time graph for the cards. So it should be a cosine graph, okay? So it should look something like this. Because according to the motion graph, when time is equal to 0, it's at the maximum displacement, which is amplitude here. And at time equals to t over 2, it's at the maximum displacement as well, but in the opposite direction. And then at time equal to t, come back to the origin point, which is the amplitude here. And this is a VT graph here, and it's a negative sign function type of graph, okay? Because VT graph, or the velocity versus time function, is the derivative of the position versus time function, okay? And the derivative of a cosine is negative sign. And this is the acceleration versus time graph, okay? Should be a negative cosine graph because the derivative of negative sign is negative cosine, since the acceleration versus time graph should be the derivative of the velocity versus time graph, okay? And for the last question, well, so now we assume that there's no friction between the cars and surface, so therefore the position versus time graph will become something like this. So the vibration of the amplitude is the same, but the time will be a little bit faster since now there's no friction was involved. So we basically treat a rough surface as a smooth surface. Okay, so it will be less resistance when the car was moving on the surface. So it should look something like this, which is let me see. And then the speed versus time graph, or the velocity versus time graph should look something like this. Oop. And the acceleration versus time graph should look something like this. And these are the answers for this question.